Everyone, this is Modula and Podrick, and we will be informing you all about what is going on in the digital world.
Welcome to the future, humans. Let's start.
So picture this. Out on the Texas plains, something absolutely massive is rising from the dust. Now, at first glance, it looks like a new microchip factory, but what you're really looking at is the setting for an incredible story of global ambition, a flat-out war against the laws of physics, and a high-stakes gamble that could literally reshape the future of technology.
And the price tag for this gamble? A jaw-dropping $50 billion. Let that sink in for a second. We're talking about one of the most expensive and complex construction projects in the entire history of the United States, ever.
So why the astronomical cost? Well, because this facility is so much more than just one company's balance sheet. You see, it's a strategic asset. It's designed to be America's champion in the incredibly fierce, global race to build the world's most advanced computer chips.
But to really get why this factory is already running into so many huge problems, we actually need to hit rewind. We've got to go back and take a look at the company that's building it, Samsung.
You know, it wasn't that long ago that Samsung was an absolute titan. Back in 2015, they were on top of the world, even making the processors for Apple's iPhones. But then, well, things started to slide. A few internal mistakes, some tech stumbles, and suddenly their yields, that's the number of working chips they can make, just plummeted. They lost the trust and, more importantly, the business of huge customers. So in 2021, they announced this Texas factory. This was going to be their big comeback play.
And you know, the first plan was actually pretty smart. They were going to build the factory around a 4-nanometer process. Now, that's a mature, safe technology. They knew the recipe inside and out. It was a solid, predictable, and frankly, a safe bet.
But then, right as construction was getting underway, a single decision was made, and it sent the entire project completely off the rails.
Suddenly, the AI boom just exploded. All at once, 4-nanometer chips felt like old news. The new cutting edge was 2 nanometers. Now, to give you an idea of that leap, it's like going from writing a word on a grain of rice to trying to etch it onto a single molecule. The precision is just mind-boggling. So, feeling the pressure, Samsung made the fateful call: pivot the entire factory to this brand new, totally unproven, and insanely difficult technology. They turned a safe bet into absolute chaos.
And the consequences? They were immediate, and they were astronomical. That one change, from 4-nanometer to 2-nanometer, caused the budget to explode from an already massive $17 billion to nearly $50 billion. And that was before they'd even finished the foundation. Because, you see, before you can even dream about making these tiny chips, you have to conquer the Earth itself. And in Texas, the ground was definitely not on their side.
Now you're probably asking, how can simple dirt become a multi-billion-dollar headache? Well, when you're working at a scale smaller than an atom, everything matters.
The big problem was the Texas soil. It's a type of clay that creates constant, microscopic vibrations. Now, you and I would never notice it in a house, but for 2-nanometer chip making, a vibration smaller than an atom is like an earthquake. It can wreck a multi-million-dollar batch of chips in an instant. So they had to declare war on vibrations, drilling 20,000 deep shafts into solid bedrock just to create a foundation that is absolutely, perfectly, unshakably still.
And the challenges just kept piling up. They couldn't rely on Texas's power grid, so they had to build their own grid within a grid. They needed 15 million gallons of ultra-pure water a day, so they built their own water factory. And the air? They had to build a clean room larger than 10 football fields with air so pure it's one of the cleanest places humans have ever created. So they conquered the ground, they tamed the power grid, they mastered the water supply, and they literally purified the air itself. You'd think the hard part was over, right? Well, according to one source, all of that was just the warm-up.
Yeah, that's right. After solving all of those incredible physical engineering problems, the true fundamental challenge finally showed its face. And it had nothing to do with concrete or steel. It was all about people.
To get why that is, you have to know one word: yield. It's really simple. It's the percentage of chips you make that actually work. A high yield means you're basically printing money. A low yield means you are literally burning it. In this business, yield is everything.
And when you compare Samsung's strategy to their main rival, TSMC, it's just night and day. See, TSMC perfected its process in Taiwan first and then basically copied and pasted it to their new factory in Arizona, complete with an experienced team and a guaranteed customer in Apple. Samsung, on the other hand, was trying to invent a brand new process in a new country with a new workforce and no customer. You see, TSMC has this huge advantage because their entire company is obsessed with one thing: getting the highest yield possible. This gets them the best customers, like Apple and Nvidia. Those customers give them tons of data, which helps them perfect their secret recipes even more, which in turn attracts, you guessed it, even more customers. It's this powerful, virtuous cycle that's almost impossible to break into.
So it really looked like the story was over. You had this marvel of engineering, this incredible factory, but without the experience to get the yields up, it was basically a ghost town. And then, at the 11th hour, a completely unexpected lifeline appeared.
Tesla, yeah, that Tesla, whose headquarters is just down the road in Austin, stepped in. They signed a massive multi-year deal for Samsung to be the exclusive producer of their next-generation AI chip, the AI6, right there, in that Taylor factory.
And look, this is not just any chip. The AI6 is the brain that's going to power Tesla's entire future. We're talking its self-driving cars, its humanoid robots, and its massive AI supercomputers. The success of this one single chip is absolutely critical to everything Tesla wants to become.
So why make the deal? Honestly, it was a move born out of mutual need. For Tesla, they get an exclusive production line, super close to home, with deep control over the whole process. And for Samsung, they get the one thing they desperately needed: a real customer, a real reason to finally turn the lights on and start the long, painful process of tuning the machines and raising that all-important yield.
But let's be crystal clear. This is a lifeline, not a guaranteed success. It is a massive, high-stakes gamble for both of them. If Samsung can't get the yields up to where Tesla needs them, this whole partnership could collapse, leaving both companies in a really, really bad spot.
And that really brings us to the core lesson of this whole saga. The story of the Taylor factory is a huge warning sign. It proves that you can pour billions of dollars into concrete and steel and the most advanced machines on planet Earth, but you can't just buy excellence. You can't build that deep institutional knowledge overnight.
Which leaves us with this final $50 billion question. Samsung has some of the best engineers in the world. There is absolutely no doubt about their technical skill. But can that sheer engineering brilliance be enough to save a project that was maybe set on the wrong path from the very beginning? The future of a $50 billion factory and a huge piece of America's chip ambitions is hanging on that very answer.